Hello, this is lesson 3.9 as to how to fill out our Blackline master. So our first question is CDEF a parallelogram? And how do you know? So I'd like you to take a look at the picture, and there should be some markings in the picture that tell us that it is truly a parallelogram. When I look, these arrows on the sides tell me that CD and FE are parallel to each other, and DE and CF are parallel to each other. So I'm going to say, yes, it is a parallelogram because opposite sides are parallel. Segment CD is parallel to segment FE, and segment DE is parallel to segment CF. All right, now that I know it's a parallelogram, our goal is to find everything pretty much that's missing in this picture. Every angle that's missing, every segment that's missing, and be able to fill out where and what they would be, what their measures are, and then explain our method. So explaining our method could be a variety of different things. From our table that we used in class the other day, parallelogram has sides, angles, and diagonals that follow all of these properties. So we could use any of these properties to help us. We can use anything with parallel lines and their angles that they formed. Some of those angles are going to be congruent that we can use. We can use vertical angles are congruent. We can use linear pairs are supplementary. All of those pieces fit together. So as we go down the list, let's see what we can find as congruent. So segment DE, the length from D to E, that's the side of my parallelogram, and opposite sides are parallel, but opposite sides are also congruent. So when I look at this, DE and CF are going to be the same measure. So I would be able to say that DE measures 3.7 centimeters. So I'm going to say 3.7 centimeters. And my explanation is that opposite sides are congruent. All right. DG. DG is part of the diagonal of a parallelogram. And when I look at what that has to do, diagonals are bisected. Bisected means cut in half. So DG is one of those halves. The other half is 2 centimeters. So if this half is 2 centimeters, the other half is 2 centimeters. Notice that I'm also putting those lengths in my picture, in my diagram, because eventually I may need those pieces. So the diagonals are bisected. All right, length of CE. C to E is the length of that entire diagonal. Now I notice from C to G is 2.8 centimeters. That means on this other diagonal, it's also 2.8 centimeters. So from C all the way to E, I'm going to put those two lengths together, and they equal 5.6 centimeters. And my reason is that my diagonals are bisected, and it's the total diagonal. All right, C to D. C to D is another side. Opposite side is FE, and that's 2.2 centimeters, so this side is also 2.2 centimeters. And my reason, opposite sides are congruent. All right, now I'm going to start in on the angles. So the angles, angle CGF. CGF is this angle right here by G. G's in the middle, so G is where my arc is. This angle and the 118, they're across from each other. They're made by the two lines crossing. So that angle is also 118 degrees because those are vertical angles. Vertical angles are congruent. All right, so we're going to have to move up and down a few times. So here we go. Angle EGF. EGF is this angle by G on the inside of the other triangle. So that angle and the 118 form a nice straight line. So those two angles form a linear pair. So if I take 180 and I subtract the 118, I end up with 62 degrees because linear pairs are supplementary. Okay, 62 degrees. Angle DEG. DEG is this angle by E. And when I look at that one, this is what I'm going to get my highlighters out for. It's part of my parallelogram that comes in, goes all the way down to there. I know I went past G, but if I take a look, here's my other parallel side. If I have two parallel lines cut by this diagonal that acts as a transversal, these two angles are alternate interior angles, and alternate interior angles are congruent. So that is also 28 degrees. Because I had parallel lines, the sides of my parallelogram are parallel, alternate interior angles are congruent. All right, GEF. When I take a look at GEF, I might need a few other angles before I can get to GEF. GEF is this one right here. I notice that it's part of a triangle, and that triangle has a 62-degree angle and one that I don't know yet. But if I go back to that parallel line idea that I had up in number 8, this angle at the top is 67.2 degrees, and I have a parallel line with this diagonal coming down to this other parallel line. These two angles are congruent, so this is 67.2 degrees as well. So now I have a triangle in which I know two of the angles. I should be able to find the third angle. If I take 180 degrees and subtract the 62 and subtract the 67.2, I end up with 55.3 degrees. And that is what my missing angle is, 55.3 degrees. And to get that one, I used parallel lines, alternate interior angles are congruent. That gave me my 67.2. It then used, or I then used, my triangle sum to find my missing 55.3. Triangle sum, remember, says that angles within a triangle add up to 180 degrees. Got to grab another pen, just a sec. All right, so the next part, angle, measure of angle DCG. DCG happens to be this angle in that triangle. And again, if we use our parallel lines, alternate interior angles, here's a parallel line, here's that transversal that comes down, that parallel line again, these angles right here would end up being congruent. So if that angle is 55.3, angle DCG is also 55.3. We used our parallel lines, alternate interior angles being congruent. All right, last two. Angle EDF. EDF is this angle up here that I need to find. Now, this angle up here. So this angle is part of this much bigger triangle DGE, in which I know one angle is 118 and the other angle is 28. I need to find the missing one. So this missing angle is part of my triangle sum. If I take 180, subtract 118, subtract 28, I end up with 34 degrees. So this angle is 34 degrees from my triangle sum. And the last one, angle DFC. D to F to C is this angle right here. And these angles, the one that you just found, that was 34 degrees, and the one we're looking for are again alternate interior angles. Here's my parallel line, my transversal, back to that parallel line. So again, 34 degrees because we had parallel lines. Alternate interior angles are congruent. All right, that gets us through our Blackline Master for 3.9. Your assignment then is the worksheet that's 3.9A. All right, good luck.